we're going to get started with our dangerous dyes. So we're going to be looking at certain food dyes, synthetics, food dyes that are approved by the FDA, and we're going to determine if they are safe for consumption or not. Before we begin, it's the only time I'm going to have you guys interact, so I promise. If you want to participate, just raise your hand if you've ever consumed one of these foods before. And of course, we can probably not see this so great. I apologize for the coloring there, but that's Lucky Charms. Yeah, Jolly Ranchers. Okay. Candy corn.
Oh yeah.
The Pop-Tarts.
Oh yeah.
Skittles. Okay, good. I saw a lot of hands. And if you raise your hand for every single item, do not feel shame because I would have done the same thing. But if you did raise your hand, that means at some point in your life you have consumed a synthetic food dye, also known as an artificial food dye. So these artificial food dyes, the FDA talks about food dyes as color additives, and they're defined as any substance that imparts color to a food. This is both for synthetic and artificial as well. And for today's purposes, anytime we refer to a synthetic food dye, we're going to refer to it as artificial food colorings, AFCs, because that's what the literature does. So just to keep things consistent, this is what we're going to be using. So by the numbers, since 1955, we've seen an increase fivefold of consumption of AFCs in the United States, and the main target is children. And one study found, they took products in a store that were marketed towards children, and they found that 43% of the products contain these AFCs in them. A separate study found that by the age of 2, 94% of people in the U.S. have consumed Red 40. Which probably includes most of us. Additionally, manufacturers are pouring about 15 million of the AFCs into our food stream every single year. And in the United States, 90% of these AFCs include Red 40, Yellow 5, and Yellow 6. And so, today, there are 9 that are currently approved by the FDA. We're not going to talk about all 9, we're just going to focus in on 4 particular ones. The Red 40 and the Yellow 5 are a part of that 90%, so we're going to look at those because those are most popularly used. And then Red 3 as well as Blue 2, we're going to look at those because there has been some alarming information about those as well. To begin, we're going to look at Red 40. It was found in a study that Red 40 causes DNA damage. So this was a study done, they did 2 different ones. They did an in vitro and an in vivo. The in vitro was with the human cell line, and the in vivo was with mice. And they did a comet assay on these, and this just detects if there's any DNA breaks in a single strand or a double strand. The comet assay, it kind of looks like a comet or like a shooting star, and that's referred to as the tail. And so they measure that tail, and they see the fraction of DNA that's in the tail. They find the product of those 2 things, and that's called a tail olive moment. And the tail olive moment, the higher or the longer that is, the higher the DNA damage is. And if you look here at figure A, this is our in vitro test. So this is with that cell line. As the dye concentration increased, the tail olive moment also increased, which means there was higher DNA damage. You can also see here, this is the in vivo test. So the white bar here is the accepted daily intake for these mice, and then the black bar is 2 times that amount. And it was found over time that the tail moment got longer, which means DNA damage was detected again. And so the fact that the in vitro and the vivo match, it's reassuring, because if they didn't match, then that would cause some speculation at the data. Also, Red 40 is known to cause colonic inflammation, and this particular study was looking into colorectal cancer. It's been on the rise in young adults for the past 40 years, and they thought maybe Red 40 had something to do with it. So they looked at the inflammation of the colon. They did that by looking at the foci count. These are like microscopic visualizations of tumor cells. In figure A and B, that's what we're looking at. Figure A was the proximal colon, it's up here more, and then figure B is the distal colon and rectum. And in the proximal colon, they found that Red 40 really didn't make a difference, but as we moved into the distal colon and rectum, Red 40 increased the count of foci that we were seeing with and without a high-fat diet. So to explain that a little bit, if you can see this here, this is a low-fat diet with Red 40, high-fat diet with Red 40. And you can see that the difference here, this Red 40 did make a difference alone, but with diet, it was even more. And that's a trend that we're going to see as we go through. A histology score was done in figure C here. This is the degree of pathological inflammation. And again, we see that red 40 caused decrease by itself along with the high-fat diet. And then they also did a study here on the inducible nitric oxide synthase. And again, they found, and this is a marker of inflammation, so that's why they were trying to see how many cells were positive for this molecule. And they found that, again, red 40 alone has an impact as well as a high-fat diet. And this is kind of concerning because when you think about what we'd be finding these AFCs in, it's mostly going to be something that's high in fat. You're probably not going to find something low fat with a synthetic dye in it. They just don't really go hand in hand. And so this is more of what we're looking at here in our bodies. Moving on to red 3. So this is a popular one that's been in the news quite a bit. Red 3 was found to cause reproductive harm. This was a test done in albino rats. So they were fed a certain amount of the red 3, and then they measured the relative organs for the male and female for both sexes. It decreased for both of them. And they also found that there was a reduction of hormone production in both male and female albino rats. And so one of these being the red 3 destroys oocytes, and the oocyte, if that is thrown off, that throws off the whole endocrine system, so all your hormones get thrown out of whack, and that can be really bad because it leads to lower levels of estrogen and progesterone. Additionally, there's an enzyme called aromatase, and it catalyzes the biosynthesis of estradiol, which estradiol is the form of estrogen that's most common in the reproductive years of one's life. And so it was found that red 3 reduces the aromatase activity, so in turn this reduces the estradiol production, which is a necessary hormone for pregnancy and birth. And so then we'll go into yellow 5. Yellow 5 was found to cause lifespan changes. So this was done in a worm strain. The reason they used a worm, I thought this was kind of odd at first, but worms are used to model, this particular kind is used to model aging in humans, so that's why they chose this subject. And you'll see the word tartrazine here. These guys have a lot of different names. So yellow 5, tartrazine, they're the same thing. And so they found that there was as the concentration of yellow 5 increased, the lifespan decreased of these worms. And that's kind of concerning if we're thinking about, oh, well, I eat that, so what does that say about me, you know? And so this first one here is the acute, and the next is the chronic. And it was found that the acute was done with like 48 hours, and there was a little bit of a difference here, but the chronic, which was done over a longer period of time, had more of a lifespan change, a decrease. And to kind of back that up as well, lipofuscin, this is an autofluorescent material that's found in cells that are aging. It's kind of a pigment, an age pigment. So you can see it as cells get older, you'll see more of it. And it was found that worms treated with AFCs presented a higher amount of lipofuscin. And especially, there's a bunch of different dyes here, but we're going to be looking at tartrazine, the yellow 5. You can see that that was the highest one. And this axis over here, integrated pixel density, this is what we're talking about here, the density of this that we're seeing. A is just the control. You might not be able to see it too well, but there's a little bit here, and that's where this is coming from. And then if you look at E, that's where all this is coming from for the yellow. So there was more accumulation of this age pigment, which just supports the fact that, okay, they're aging quicker, so that correlates with a decrease in lifespan. Our last dye that we're going to be talking about is blue 2. And this one's pretty interesting because it increased tumors in rats, but not mice. And so that's like, those don't really, they should match, you would think, but they did say that there might be a reason for this due to the time span. So the mice one was done under 2 years. Possibly that's not long enough for them to actually understand or get a good reading. And so the rat model was used, and it was found that there was a significant increase in brain gliomas as well as mammary gland tumors. And brain gliomas are found in cells that support the brain and the spinal cord. It's pretty important areas of our body to be finding tumors in. And you guys might have heard this before in the news, hyperactivity in children. A lot of times people hear like, oh, I stopped giving my kid, fruit snacks because of the AFCs. And so there was a test that was done. It was a double-blind placebo-controlled experiment, and it was done on 3-year-olds in the UK. They were given a drink containing AFCs. for a period of time. And originally they were assessed by a clinical assessment using these two scales here. And then the rest of the time they were analyzed by their parents. So the results we were getting was the parent feedback. And from the parent feedback, it was saw that there was a reduction in hyperactive behavior during the withdrawal period, so when they were off of the drink. But when they were in the active phase, when they were taking the drink, the behavior increased, that hyperactive behavior increased. But the only thing that's a little concerning with the results here is that the parental report produced these conclusions, but the clinical assessment did not back these up. And so to kind of understand that, 15 of the 59 parents that withdrew their kids due to like excessive hyperactive behavior, 9 were during an active week, 6 during a placebo. And those numbers are fairly close, so that kind of makes this a little bit wish-washy. There's a little bit of room for discussion on whether this is safe enough. It's not like the other stuff where we have like hardcore data, it's a little bit more up for discussion. Currently there are some bans on AFCs, so there is a difference between bans and requiring warning labels, which I didn't know. So, and maybe some of you guys are familiar with Europe banning certain AFCs. The research that I did saw that they don't ban them necessarily, they just make you put a warning label with all this information on it. And companies are not wanting to put a warning label, oh, this could cause cancer, blah, 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 because that decreases their marketing. So they don't necessarily ban it, but they must include a warning label, so companies over there are not using the AFCs as much as over here in the US. But recently, California just became the first state to ban an AFC. They banned Red 3. This will become effective in 2027. And this comes about 30 years after they banned it in cosmetics. So if you can think about that for a second, it's banned in cosmetics, but yet we're still allowed to eat it. So that's just something to chew on. Yeah.
So to speak.
And Peeps, so some companies like Peeps are no longer containing Red 3. Some companies are taking it upon themselves to just get rid of these AFCs based off the data that they've seen. And so what do these companies do? They don't just completely get rid of their products, they turn to a natural alternative. And so they're using natural colorings, which are often coming from your fruits, vegetables, other plant alternatives. Some European countries are using rice starch and cornstarch to try to get that yellow color. Nestle, the Butterfinger, the yellow center, they're using annatto, it's a seed. They're trying to use that to get the color. Body Armor, the popular sports energy drink, if any of you guys have seen that. If you hold a Body Armor next to a Gatorade, the Gatorade's like super vibrant, and then the Body Armor is not as vibrant. And this is due to the fact that Body Armor uses natural colorings like beta carotene and other fruits and vegetables, whereas Gatorade does use that synthetic AFCs. So that's why you would see that color change. And another company, General Mills, they make Trix cereal. They're wanting to get rid of AFCs, but a problem they're running into, if you can see here, there's blue and green over here, but in this one there's not. This is their current product, and this is what it would look like if there wasn't AFCs, because they can't find a good alternative for those blue and green hues. And the reason for that is because they're not stable enough, and we're going to get into that in just a second. And as you can see here, they still have the red colors. This is from strawberries and radishes. And so like I was just talking about, well, why aren't these natural colors as stable? There's a chemical reason for that. So if you look at red 40 and yellow 5, these are your synthetic, these are your AFCs. And right here is the sulfur trioxide, there's an alcohol group here. These are things that are going to be more reactive. And so they're going to make stronger bonds as they're entered into the food, and they're going to hold better, they're going to be more stable. Whereas beta carotene is a fatty acid chain with 2 aromatics, not very reactive. It's not going to interact as well with the food. And so because of that, it's going to break down easier and lose its color. Because you can see these conjugated double bonds. In this natural one, that's what's producing the color. So when that breaks down, your color is going to go down as well. And so because of that, there is some support for AFCs, mostly by companies. They're saying that they're more stable than natural dyes, so more vibrant colors, as well as you're going to have a longer shelf life in terms of the color is going to hold for longer. Also, there's support because all these studies have been done on human cell lines and animals, not on humans actually. So we need to do more tests on how it actually affects our bodies. And a big one that I really want to hit here is the lack of mechanistic insight. So everything I've given you is an observational change that they noticed, but nothing is talking about, well, how are they actually interacting in the body? How are they getting metabolized? And the reason for that is we just don't know enough about it. And so a lot of these studies said, oh, well, our next step is to find the why to the what. So that's where they're going to be going. Additionally, earlier we were talking about inflammation and how I was talking about that high-fat diet with the AFCs being combined. We just don't know, well, is one worse than the other? We need to know more about how they're actually interacting. And additionally, the acute consequences compared to the chronic ones, the chronic was worse. So it's kind of that idea of, well, too much of anything can be a bad thing, right? So you have people saying that as well. If I eat a bag of Doritos today, am I going to get cancer later on? If I eat Doritos every single day for the rest of my life, could be a difference, right? And so that's a big deal as well. So in conclusion, we've looked at 4 different dyes. We looked at red 40, red 3, yellow 5, and blue 2. Red 40 causing that DNA damage and clonic inflammation. Red 3 has reproductive harms. Yellow 5 has negative lifespan changes with the lipofuscin accumulation to back that up. And then blue 2 caused tumors in rats. Also, we discussed hyperactivity. There's a little bit of room for discussion there because of the way the tests are conducted. And there are currently bans on AFCs, as well as requiring those warning labels, but we do offer, there are natural alternatives that exist. And so, again, we're going to bring these back up. Are you still hungry? Now that you know some of this information, does this stuff still look appetizing to you? I know for me doing this, every time I go to get something out of my pantry, I'm like, I don't know, like, should I eat it, should I not? And so, yeah, that is all I have for you guys. If you have any questions, I can take those.
I have 2. So the AFCs, I assume, are cheaper too.
Oh,
I don't know if you've
I didn't really come across
And I hear
anything
that's
like
what
that,
companies do.
but they're probably mass producing them, whereas your natural, you're gonna have to go, you might have to go through like farmers, you know, and then there's probably more costs there, yeah.
And the other thing was really just a comment about when you were talking about the AFCs and hyperactivity. You know, you hear things in the media all the time about, or just people talking about giving sugar to their kids and how it makes them hyperactive. That's not actually true, is it? It's not sugar that actually do it. I thought they discovered that it was because it's sweet and they like it. So when kids like stuff, they get more excited. That the sugar itself is not actually doing it.
Yeah, that could be, and so
isn't that true?
I'm not sure completely, but the fact that a lot of so like a test like that, if they're going to be going off of like the parents' assessment and even these clinical assessments, it's not like as easy as, oh, let's analyze the DNA. It's, well, let's get the feedback and see, like, it's just a different scale. So we would need to know more about how these are interacting in the body, I think, to actually answer that question as far as the AFCs go. Yeah.
For the AFCs, did they use a constant food coloring for that, or did they use multiple? Do you know?
So it kind of depended on the experiment. So, like for example, the DNA damage and the clonic inflammation, they just used red 40. But the one with the yellow 5, the lifespan, there were a variety that they used.
In particular to the children's study?
Oh, the hyperactivity study? They used various ones, yes. They didn't have like a chart that I could show you, like these are the results for each one, but they did use a variety, and I think the biggest one was yellow 5 that they used. Yeah.
So maybe not a question, but just a comment on that hyperactivity study. Maybe these food dyes aren't really broken down because they're more stable. They're not really broken down and flushed from the body very quickly.
Yeah.
So you see more of an effect within a chronic condition than an acute condition.
Yeah, that is
possible. These compounds are building up.
Yeah.
And so maybe there's a clearance factor in the body where these compounds are building up. So long term, we start to see effects.
Yeah.
Do they build up in the body?
For hyperactivity.
They weren't doing so many tests on like how they were going through the body, like where they were coming out, but I do think that they come out, like they don't build, I don't necessarily think they build up as much, because I did see some of the results said that they found like in urine samples and stuff, it was coming out, so Yeah, but I think that is all the time I have for you guys today. Thank you guys so much for coming.